Okay, this is section 3.2, linear combinations and ax plus by equals c. Here's your journal choice. I actually had to write this disclaimer because I did have a student once write about the animal moles and it was weird. Okay, objective and what's the point? This is a good way to write equations because sometimes real world examples will have things listed out in a linear combination form. It's very easy to write an equation of a line when it's in this form. And we're just going to talk about it a little bit. Words to know. What is a linear combination? It is an expression in which all variables are raised to the first power. So you can have no exponents, and you're not multiplied or divided by each other. Okay? We are going to look at a worksheet, for example, here to see if it follows this. We're looking for no exponents and no multiplication of variables. So the question is, are these linear combinations? No exponents, no variables being multiplied by each other. This is a linear combination. Usually it looks like ax plus by. Okay, you could have more than that, but here we go. No exponents, no variables being multiplied. That's a yes. See the exponent? Bad. This one passes the test. There are 3 exponents here. I mean, not 3 exponents, excuse me, 3 variables, but that is okay. E, yes, yes. Problem there, so that's a no. How about this one? You would have to distribute to c, oh my gosh, c squared. Can't have that, that's a no. How about this one? This one makes some people feel uncomfortable. What about the square root of 4? It is fine, it is just the coefficient. That is okay. Yippers, this one's fine. This one, square root of x. This is actually not okay because that is an exponent. A square root is an exponent of 1/2. I don't know why they always throw this in so early before we talk about it. That'll be, I think, second semester. But this is not a case. And this one's okay. Okay, you're looking for ax plus by type form here. I just did that. Okay. A standard form of equation for a line, the form ax plus by equals c, where a and b are not both 0. So why can't a and b both be 0? Well, if a and b are both 0, I have 0 equals c. That's not a line. It's just 0 equals a number. It may not be anything, or it just may be a point, possibly. But that's why a and b both can't be 0. One of them can be 0, and that's alright. A lot of textbooks go even further and say a and b can't be fractions, so you might have to clear out the fractions on those. Continuous function. We've talked about this, continuous and discrete. I say you could do the pencil test, meaning can I trace it forever and not pick up my pencil? If you don't have to pick up your pencil and you can trace forever and ever and live a happy life, then it would be a continuous function. The discrete function would be if my pencil had to pick up at all. Continuous functions that we've talked about so far this year, y equals kx squared, continuous function. Discrete, like I said, you pick up your pencil, y equals k over x. This is a discrete function when looked at as a whole. If I was only going to isolate it and say only quadrant 1, that would be continuous. Alright? Usually the discrete function, and this is not completely accurate, when x and y must be integers. A lot of times discrete functions will be those real world problems where you can't have half a person, or you can't have broken products, it says here, when you're looking at integer values for domain. But it doesn't have to be. It could be any time there's a break in the graph. Basically, you don't connect the dots in discrete function. Things to note, if no details or descriptions are given, you can assume it's going to be continuous. That is, you can assume that you can pick whatever value you want for the independent variable x. This is just another thing to help you out. It is best to use improper fractions from here on out, and we've mentioned this in chapter 1. Messy decimals aren't usually my idea of a good time, and rounding errors I think you guys are prone to make. Alright? This may require concentration. He's really thinking hard. He's a little wobbly. He's funny. Okay. Write a linear combination representing the total, and then we're going to see if it's discrete or continuous. Here we go. In football, touchdowns are worth 6 points, extra points are worth 1 point, and field goals are worth 3 points. Suppose that the Manatee Cougars, which I have an issue with that name. If you are from Manatee, you should be the Manatee Manatees. Just saying. Score T touchdowns, P extra points, and F field goals. Write an expression that gives the total number of points scored. Okay, so total points. Let's see P for points. What do we have here? 6 points for touchdowns. So 6T, 6 points for touchdowns. I'm going to add to that some extra points. Let's call it 1 for each. 1 point for extra points. Field goals are worth 3 plus 3 points for field goals. See how easy that is? Write an expression that gives the total number of points scored. That's what we did. Oh, they said expression. My bad. Don't do this. Don't put P equals in. Expression does not have an equal sign. And then, what's it want to know? Discrete or continuous? Can you have a half a touchdown? Can you have a half an extra point? Can you have half a field goal? No, that's weird. That's discrete. Yvonne bought P pounds of peaches at 79 cents per pound. Grapes. Okay. So, 79 cents for peaches, yum yum, plus $1.99 for grapes, scrumdiddlyumptious. And can you have half a pound of a peach? I'm guessing you guys probably don't do lots of grocery shopping, but you can. So if that's my, oh, why am I writing that? Continuous. I always ask myself that. Can you have half of this? Can you have half of that? That will be your indicator. I like these. These are fun. Chemist. These are not fun. I'm going to tell you a story. Once upon a time, Mrs. Bruno was in Algebra 2, and we had to do all of these mixture problems, and they stressed me out. I told you Algebra 2 was my hardest year of math in my whole career, I'd say, until I was a junior in college. I thought Algebra 2 was so hard. These were the ones that kicked my butt. But they're not that hard. He mixed A ounces of a 30% chlorine solution with B ounces of 40%. Remember, percent means out of 100. So this is talking about 0.30 of A plus 0.40 of B. If I was actually going to write an equation, not an expression, I would have wrote equals 18. This is extra information for this exact problem, but if I was looking to solve it, I would have said it equals 18. Can you have half of an ounce? Yeah, you can. Continuous. Alex bought P flats of petunias at $12.99 each and B flats of begonias at $8.99 each. Write an expression. Okay. So $12.99 for petunias, $8.99 for begonias. I like to say begonias. I think it's a funny word to say. Okay, and here's where my method fails you. Can you have half of a flat of petunias? If you don't know what flats are, I think they're those things. They kind of look like little ice trays, and they have those little flowers in them. You can buy half a flat, but that was a really bad thing for me to just tell you right a second ago, because there is a limit to how you can break this down. You can't keep breaking them down. Like back in those pounds examples, I could have half a pound, I could have a fourth of a pound, I could have 0.1 of a pound. This, at some point, you can't break them up anymore. This is discrete. Describe a situation leading to this equation. There's lots of examples. You buy 40-cent candy bars, 60-cent soda, and you spent $24 or something like that. You can write whatever you want, as long as it's school appropriate. Okay, on a quiz show, 20 points are given for correct answers to regular questions, 50 points for correct answers to bonus questions. If a contestant answers 5 regular questions correctly and 7 bonus questions correctly, how many points does she have? Well, this is where it's nice to write up your little formula. 20R plus 50B. 20 for regular, 50 for bonus. Plug in the stuff here and answer the questions. Okay? I think you can answer them all. I don't think I need to go through these all. 9. Helene bought L 74-minute recordable CDs at this much. M 80-minute recordable CDs at this much. Suppose she spent $12.40 and she bought 10 80-minute CDs. How many 74-minute CDs could she buy? Again, start with this. The 74 doesn't go with the L, it's the cost per unit. So 0.58 L plus, I don't even know what. Oh, there it is, 95 cents. 0.95 M. Okay, that's your linear combination. Now plug in what they give you. She spent $12.40, so it's going to be equals $12.40 here. Not only that, she spent 10 80-minute CDs. The 80-minute CDs were M, so then you're going to plug 80 into here and solve. Okay, I don't think we need to go over the last one either. I think this should be pretty easy for you. Reminder, slope formula, y2 minus y1 over x2 minus x1. x1, y1, x2, y2. Be very careful with your negatives. When you subtract a negative, it becomes a positive. Okay, that's all I have for you today. And see ya!